So now we're looking at example 4. Yes, we skipped example 3. That is using the graphing calculator, so we do not have that use for it in this class. So we're skipping that and just jumping into example 4. So we're going to be using surface area formulas. Once again, that's on page A95 in the back of your book for all the formulas. This problem, it says a manufacturer designs this bearing shown below. To prevent corrosion, the manufacturer needs to coat the bearing with grease. So they need to take that grease and they need to put it on basically the entire inner surface, which we can say it's the same thing. Okay? So we have two different bearings. The smaller bearing has the linear dimensions that are 1/2 of what is shown here, and then the other one is the regular. It says, does the smaller bearing require 1/2 the amount of grease or not? So the first thing we should do is we need to figure out the surface area for the larger and the smaller one to determine what it is. So what we need to do is let's use that surface area formula. Surface area for a cylinder, there we go. Surface area for a cylinder is 2 pi r squared plus 2 pi r times h. That's 2 circles, and then that's covering that very long circular centerpiece. Okay? 2 circles are the top and the bottom. Understanding the formula is one thing that you guys have kind of done in the past, but what we're going to do right now is let's look at the smaller bearing first. So it is half the dimensions, so that means the radius is half and the height is half. So our radius is 1.25 millimeters and our height is 10 millimeters. The larger, the radius is 2.5 millimeters. You can say larger or the regular. Those are both correct. And then the height is 20. Plugging everything into the surface area formula is what we need to do next. So that is 2 pi 1.25 squared plus 2 pi 1.25 times 10. Plug that into your calculator. You should get, ignore doing it with the pi's because we don't need to plug those in this case. We are going to get 28.125 pi millimeters squared. We are going to be comparing the regular and the smaller, so the pi's are irrelevant in this case. So you don't need to worry about it yet. Now looking at the regular or the larger bearing of the two, we're going to do the formula. So 2 pi 2.5 squared plus 2 pi 20 times 2.5. You can do them either way. It's multiplying. All right, so that gives us 112.5 pi millimeters squared. I'm kind of leaving a separation so you guys can see the difference. So let me make this a little smaller. Oh, not that much smaller. Give me a second. There we go. Giving us more room to work. I'm going to just do that. So now we need to see if it requires 1/2 the amount of grease. So what we're looking at is we need to take the smaller piece over the larger piece to see how much bigger or how much smaller the surface area is. So we want to do the smaller of the larger because we want to see how much smaller the, now I'm going to say it again, smaller bearing is. So, we've got 28.125 pi over 112.5 pi. This is why I said the pi doesn't matter. The pi's will cancel, and you will get 1/4. So the smaller bearing takes up 1/4 the amount of grease because it has 1/4 the surface area. So to answer the question, you can say no, it only takes 1/4 the amount of grease or something like that. That's to answer the question for A. Now for B, it says, now just another example. So it says a smaller bearing has the same radius, but the height is 1/2. So we want to know, is 1/2 the amount of the grease used to coat enough to coat the larger one? So we actually already have the larger one, so we're going to use this information, and now we're going to compare it with our second option where it has the same radius of 2.5. So for B, we're looking at the radius of 2.5, that's not changing, but the height is now only 10 millimeters. So we need to find the surface area of that. That is 2 pi 2.5 squared plus 2 pi 2.5 times 10, running out of room. That may get cut off, sorry. Let's see if I can get it to fit in. There we go. So that's a really, really squished 10. Once you push that through your calculator, you'll get 62.5 pi millimeters squared. So now we want to see how much smaller this new bearing is. That's half the height, to see if it's half the surface area. So we're going to do 62.5 over 112.5, and then both those have pi's. The pi's will cancel out, and you'll get a decimal, but it's approximately 5/9. So the surface area is 5/9 times the surface. It's a little bit bigger than 1/2, which means that half the amount of grease is not going to be enough to coat our smaller bearing. So we can say it's not enough grease because 5/9 is greater than 1/2, something like that. I'm sorry, I'm running out of room on this. Okay, that's what we're looking at for this piece. Hopefully that is making some sense to you. If not, make sure to go back, watch it again. Email me if I need to make it a little clearer for you or anything like that. Okay, that is it for this lesson, and then you guys are going to be able to hop into homework.